In this video, we're going to talk about real numbers. And the set of real numbers contain a whole bunch of different subsets. And some of those subsets are the natural numbers. And the natural numbers are the numbers 1, 2, 3, 4, and so on. And a lot of times they're called the counting numbers because those are the numbers that you use to count. Then we have the whole numbers, which is the counting numbers or the natural numbers plus 0. Then we have the set of integers, which is the set of whole numbers plus all the negative natural numbers. Then there is the set of rational numbers, and rational numbers are any numbers that can be written as a fraction as long as the denominator is not equal to 0, because that's considered undefined. And the irrational numbers are numbers that cannot be written as a fraction. So when you look at the real number system, here's a picture of it broken down here. All real numbers can be broken up into rational or irrational. Rationals are numbers that can be written as fractions, and irrationals are numbers that cannot be written as fractions. And then the rationals can be broken down into those subsets. Decimals that are rational are decimals that terminate. For example, 0.35. 0.35 can be written as a fraction. It can be written as 35 over 100. So 0.35 is considered a rational number. So any number that terminates, or any decimal that terminates, can be written as a fraction. Another example is 0.7253. That can be written as 7253 over 10000. Another example of decimals that can be written as fractions are decimals that repeat. For example, 0.314314. That can be written as 314 over 999. The number of digits that repeat, you would just put that repeating sequence over that many nines in the denominator. So another example would be 0.3333 repeating. Since 3 is what's repeating, I could rewrite that as 3/9 or 1/3. Because there's only one digit that repeats, so we would only put 1 9 in the denominator. Now, decimals that don't terminate and decimals that don't repeat are the decimals that fall under a rational set of numbers, because those cannot be written as a fraction. So, for example, pi is a very famous irrational number because it's 0.31415 and it goes on forever, but it never repeats. Or another example might be the decimal 0.12345 and goes on forever. That doesn't repeat as well. So that would be considered an irrational number. So when we look at this diagram, we have reals in this big box, and it can be broken down into rationals or irrational. Okay, then within the rationals can be broken down into subsets. All the naturals are considered whole numbers because the whole numbers are all the naturals plus 0. All the whole numbers can be considered integers, and all the integers are rationals because integers, if you just write them over 1, that is a fraction. So this is what the real number system looks like. Okay, now that we have an idea of the real number system, let's get into simplifying algebraic expressions. And a lot of people get expressions mixed up with an equation, so I want to make sure that we discuss the difference between the two. Think of an expression as a mathematical phrase, whereas an equation is a mathematical sentence. In English, we have phrases and we have sentences. Okay, a phrase is just a portion of a sentence. So, for example, a phrase might be something like the black cat. That's a phrase. That's not a complete thought. A sentence is a complete thought. A black cat just crossed my path. That is a complete sentence. Okay, so an equation is a complete mathematical thought and it has an equal sign in it. So, for example, 3x plus 7 is 20. If it has an equal sign in it, then this equation, I would consider that a complete thought. And an example of an expression would be just part of that equation, 3x plus 7. No equal sign. It's not a complete thought. Okay, order of operations. When we evaluate any kind of expression, whether it's got all variables, or whether it has numbers or numbers and variables mixed, we have to follow a certain order in order to make sure that we're all consistent and we get the same answer. And the order that mathematicians and scientists have agreed upon is that we work inside grouping symbols first. So by grouping symbols, I mean braces, brackets, parentheses. And if there's more than one set of grouping symbols, then you always want to work the innermost first and work out. Inner grouping symbols first. And then you work your way out. The next thing that you want to do for order of operations is evaluate your exponents. The next step, which a lot of people get mixed up with this, and it's mainly because of the expression, please excuse my dear Aunt Sally. I would not use this. Let me make a note. Do not use, please excuse my dear Aunt Sally. That is very confusing because when you list that out, it's misleading. It makes you think you have to do multiplication before division because the M comes before the D in the expression. But the truth is you do multiplication and division together, left to right. So if you're looking at an expression and you have multiplication and division in that expression, but division is on the left, you want to do the division first. You always want to work those two operations together, but left to right. And the same thing goes for addition and subtraction. Addition doesn't necessarily always have to go first just because this acronym says it does. You always do addition and subtraction left to right. So this is why I do not like people using please excuse my dear Aunt Sally. It's misleading because people think that you have to do multiplication before division, and that's not necessarily true. So be careful and do not fall into that trap. Okay, so using order of operations, we're going to simplify the expression. Notice that I'm calling this an expression because it has no equal sign, okay? So we always do, according to our rules of order of operations, we do inside parentheses first. So the first thing I'm going to do is work inside the parentheses. And inside those parentheses, we have division and we have multiplication. Because our rule says we do division and multiplication in the order left to right, I'm not going to do 2 times 2 first. I'm going to do 6 divided by 2 first. So 6 divided by 2 is 3. So I do that first because it's left to right. Then I do the 3 times the 2. Now I've got what's inside the parentheses completed. So now the next step in order of operations is to work exponents. So I've got 6 squared here, which is 36. There is no other operations for me to do at this point, so 36 is my final answer. Okay, the next example, we have 2 sets of grouping symbols, and we always do the innermost first. So I'm going to do inside here first. I'm going to carry everything else down. So 7 minus 2, that gives me 5. So I did inside the innermost grouping symbol first. Now I've got another set of grouping symbols, which is the brackets. So I need to do inside those brackets next. So I need to do the 5 squared first. We have division and we have exponents inside that grouping symbol. So according to order of operations, I need to do exponents first. So I'm going to take the 5 and I'm going to square it. Now I'm going to continue working inside the grouping symbol until I'm done. 25 divided by 25 is 1. Now we have multiplication and exponents. According to order of operations, exponents first. So I'm going to do 1 squared, which is 1. And then I do the last step, which is multiplication, and I get -4 as my final answer. Okay, for example C, we've got multiplication and we've got subtraction. According to order of operations, we do multiplication first. So I'm going to do the 4 times 3, which is the 12. And I also have the 5 times the -1, which would give me -5. Then I do subtraction last. And I have 12 minus a -5. So that's the same thing as saying 12 plus 5. So my final answer will be 17. In example D, now we're getting into simplifying expressions using order of operations with variables in them. So we have x's in this one. We still follow the same rules. We just have to keep in mind when we do our order of operations, we can only combine like terms when we're adding and subtracting. So in this expression, we have multiplication, subtraction, and addition. We want to do the multiplication first. So I'm going to take the 2x times the 2 first. And then we have what's left, we have subtraction and addition. And we always want to do subtraction and addition left to right. I have 6x and a -4x. I can combine those because they're like terms. So that gives me a 2x, and then I can bring down the 6. Now we have addition. I have a 2x plus a 6. However, in this case, I can't actually combine those because they're not like terms. So this is as far as I can go, and my answer would be 2x plus 6. Okay, the next example, we have addition, subtraction, and multiplication. I want to do multiplication first according to order of operations. So I'm going to bring everything else down. And I'm going to do -2 times 4y. That gives me a -8y. Now I want to do addition and subtraction left to right. 6 plus 4y, I can't do that because that's not like terms. If it was just 6 plus 4, then I can add it and make that a 10. But because it's 6 plus 4y, I can't do anything with that. So I leave it alone. Now I go on to subtraction. I have a 4y minus an 8y, and that gives me a -4y. And this is as far as I can go. The next example, 4 times 5 plus 8b divided by 4 minus 20. we have in this problem multiplication, addition, division, and subtraction. So we want to make sure that we do multiplication and division before the addition and subtraction, but we want to do it starting left and going right. So I need to do the 4 times 5 first. Then I want to do the 8b divided by 4. 8b divided by 4 would be 2b. And now I want to do the addition and subtraction left to right. I can't combine that 2b with anything because I don't have another term with b in it. But I can take the 20 minus the 20 and get a 0. Those disappear, and I'm left with 2b. Okay, last example, example G. In this example, we have parentheses, multiplication, and subtraction. You always want to do what's inside parentheses first. And so inside these parentheses, because they're not like terms, I can't do anything with that. So I leave it alone. And so I'm done with my parentheses. There's nothing I can do with that. And then we move on to the multiplication, addition, and subtraction. Well, with the multiplication, I have the 7 times the 3 minus y, and I have the 4 times the negative 7. If you have more than one term inside parentheses and you're multiplying by something on the outside of the parentheses, you have to do what's called distributing, where you have to take that whatever's on the outside and multiply it by everything that's on the inside of the parentheses in order to remove those parentheses. So I have 7 times 3 is 21, and 7 times a minus y is a minus 7y. And then when I take 4 times the negative 7, that gives me a negative 28. And I'll bring everything else down. So I did my multiplication and I did it left to right. Now we're going to do our addition and subtraction. If we look at our like terms, I have a minus 7y and a plus y. That gives me a minus 6y. I can't combine that minus or that negative 5x with anything because I don't have any other x's. But I can combine the 21 and the negative 28. The 21 and the negative 28, when I combine those, will give me a negative 7. So here is my final answer for part G.